Hello again, code milkers. Recording 2 in one day because I slacked yesterday and did not record the first video that I should have. But I'm back on track. Today's question was first unique number, and this actually gave me some trouble because I was having trouble implementing a certain data structure in JavaScript, so I just left it, went with something else that actually worked. So I'll go over that in just a second. So the question was first unique number. You have a queue of integers. Remember queue, it's important. Queue of integers. You need to retrieve the first unique integer in the queue. Implement this as a class called first unique. So when you initialize the object, you initialize it with a list of numbers. Then you have two methods. You have show first unique, which returns the value of the first unique integer of the queue, or returns -1 if there is no such matching integer. Next we have add, and this adds a single integer to the queue. All right, so let's look at this first example. The input is a set of instructions. So we have first unique, that's initializing the object. Then we're showing the first unique number in our queue. Then we're adding and so forth. The second part of this input is an array of subarrays, and each subarray has a certain timing and value corresponding to a certain direction in the first array. So when we say first unique, we're using this 2, 3, 5 array to put these values in the first unique object and initialize it and form the actual queue to pull first unique numbers from. Then a blank one means that we're just showing the first unique. We're not inputting any new data into the object. And then when you see a subarray with a number in it, that means we're adding that number into it. So that's just a quick and gritty way to understand the inputs. Then the output corresponds to each direction in the order that it is written up here in the input. So the first unique obviously returns null because we're not returning any data from it. We're just creating the new object and returning that. Then show first unique, we actually need to return an integer from that. It's going to be either -1 or whatever the first unique number is. Then we have add, and that is going to have a return value of null because we don't need to return any numbers from that. So this is how they break it down. First unique, we initialize it, then we return 2 because we started with the array 2, 3, 5, and the first number we added to that queue was 2. So we return 2 because that's the first number in the queue that is unique. You should already be thinking in your head, we can use a hash table to keep track of counts easily in constant time. Then we add 5, and now 5 is repeated, so that's no longer an option for being unique because there's at least 2 entries of it in the hash table. Show first unique, it's still 2. When we added 2, that means that our new unique number is 3 because 2 is invalid now because there are 2 entries in the hash table. And what I mean by that is that the key value 2 has more than one count to it. So like its integer value in the hash table will be greater than 1. Then here we return 3. Then here we actually add another 3 to it, which makes all of our queued numbers invalid because 2, 3, and 5 have more than one count in the hash table. So we return -1. We don't need to go over these test cases because they're the same exact thing. My solution is very simple, super simple, no linked lists, no set, no map, just an array and a object for serving as a hash table. So in first unique, we are initializing the queue object and the counts. So Q, we only push a number into the Q object, into the Q array, if it's undefined in counts hash table. Because if we added more than one, that means that there would be duplicates in the Q array, and we don't want duplicates. We want it to be only individuals that are unique, because it would mess up as we iterate over the Q. You'll see that if there are duplicates, it could mess up, and it would also take a lot longer to loop through it. And then we initialize the counts for the current key num to 0, and we always increment the counts of it, no matter what, if it's unique or not unique. We increment the count as usual. And here we're just returning it, making the object. Okay, and add is just the same thing as up here in the constructor function, so nothing special there. The show first unique, that's where all the magic happens. So I don't think I needed to use this to keep the execution context. I don't think I need to assign it to another one, but we'll just leave it for now. So we are iterating from the first index to possibly the end. So we have worst case O of n for finding the first unique number. So if the given element at index I of the Q property is less than 2, then that means it has no duplicates, which means it is our first unique number. So we return that value early, which means that a lot of the times we won't be going to linear time on this. It's only in the worst case. If we come out of the loop and we still haven't found it, that means there's no unique numbers. So this is a little optimization I made. If you know there's no unique numbers, you don't need to loop them again. You just get rid of them all. You don't need them. So once you're at -1, you can safely reassign the Q property to an empty array, because it effectively is the same thing. It'll take a lot less time to tell you that you have no unique integers. Then we return -1. This would be faster if we could use a different data structure for removing and adding elements. Mostly the removing. That's what takes time. So it's an okay solution, 348 milliseconds. I'm sure some people had theirs down in the 48 milliseconds range. I tried it with a set instead of an array, and it actually made it slower, because I'm not sure why, because set should have faster delete time than just a standard array. So I'm going to do some more research on that. But yeah, that's the solution. Very simple. Hope to help. Have a good day.